Hi, I'm Brooke and welcome to Tech Tuesday at 2. This week we'll be learning all about data visualization from Kevin Dyke. Let's get started.
Good afternoon, everyone out there and across the information superhighway. This is Kevin Dyke, and I am coming to you from the Edmund Lowe Library, where today, as part of Tech Tuesday at 2, I'm going to talk to you about data visualization. First, a little bit about myself. I am the Maps and Spatial Data Curator here at the library, which means I work and basically live in the lower level of the library, managing our map collection, working with spatial data, teaching workshops, and doing all things spatial. And that includes some data visualization. So what is data visualization, first of all? To quote someone much smarter than me, data visualization can be thought of as how to communicate information through the simultaneous presentation of words, numbers, and pictures. That's a pretty simple definition from Edward Tufte, but that really does capture the truly astounding variety of data visualizations that are out there. This is a huge field we're talking about. Now here, I want to show you perhaps the most famous data visualization ever made, and it was created in 1869 by a fellow named Menard, who was a French civil engineer who was retired and just kind of whipped this up in his golden years. It's a diagram showing Napoleon's march into Russia during 1812 into 1813. And the brownish tan color is the march into Russia, and the black line represents the return trip from Russia. And the width of that line in the middle that you can see represents the number of troops in Napoleon's army. And it actually is the case where if you looked at the paper original version of this, 1 millimeter of width was equivalent to 5,000 troops. So this thing was scale accurate, which is just truly remarkable. And and if I am just going to jump into the English version of the same visualization, because I do not read French, you can see it shows just the successive losses of men in the French army during the Russian campaign. So you can see it at the start, we're talking close to 500,000 troops in Napoleon's army, and by the time they returned, less than a year later, that number was down to less than 10,000. So just truly a staggering loss of life, and that was the focus of Menard when he designed this this information graphic. In fact, he doesn't even mention Napoleon anywhere on this chart, but it's obviously implied. And you can see down at the bottom, so not only do we have a directionally accurate location, because from left to right, that is actually representative of latitude and longitude, so showing where along within Russia the campaign is moving all the way to Moscow. But then if you look at the bottom, you'll see it shows the temperature in as the winter progressed on the way back. And you can see, if you look very closely, it's very tiny, but you can see by December 6th, close to the end, the temperature reached negative 36 degrees Fahrenheit, which is just had to be a truly hellish experience for those who were still alive at that point. So that is a real uplifting and well-known data visualization. So let's think that using that Menard chart as a jumping off point. When is visualization a good idea? And on the other hand, when is it a bad idea? So first of all, it's a good idea when you have a significant amount of data. Now that may sound kind of squishy, but that's just because it is a squishy, rather subjective thing to consider. So here is a table of data. You see we have different foods, and then now this is not subjective, ranking of their deliciousness. Cake, banana flavored candy, and Brussels sprouts. But just looking at the number of rows, the number of cells, if you will, with this data, that is not a significant amount of data. Just that table is enough to get across what the point of what we're trying to prove. That cake is delicious and banana-flavored candy is disgusting. Now, looking at a different table of data, this is something that you look at it, you probably don't get a very good sense of the data. We don't see the shape. We don't see any patterns. We don't see any change. It's difficult to suss out any real meaning to this data. And what data visualization allows you to do is to present, encapsulate a large amount of data into a smaller amount of space. So it increases the data density that your viewers are able to see at once, but also understand and comprehend, all in ideally a nice, simple graphic. There is a tendency within data visualization, as with pretty much anything, towards complexity, where you just want to add more because you can, and then you end up with something as equally difficult to comprehend than what you started out with. Just more colorful and perhaps beautiful, but not communicative. So another reason to create a visualization, when you want to highlight a relationship within your data. So here you can see a couple of different charts, and we will talk about these types of graphs in a little while. But I want to show the relationship implied. If you look at the first figure, you see that's the relationship between the number of cigarettes smoked per day to the incidence of cancer amongst men. And you can see it's a very clear positive correlation, which I'll touch on a little bit later, but basically meaning the higher the one value goes, the higher the other goes, which means the more cigarettes you smoke, the more likely you are to have cancer. Hopefully at this point everyone knows that that is a thing. And yeah, so that's a not controversial thing to state at this point. But then if we also look at the plot on the right, figure 2, that shows the relationship between manufactured cigarettes per adult and rates of lung cancer. And so this shows that, and it's not perhaps not as strongly correlated as the previous one, but it shows that if you live somewhere where there are a greater just manufacturing of cigarettes, so even regardless of the smoking habits of any particular person, the more cigarettes that are just around you seems to suggest a higher incidence of cancer. And that's not to say that just being around cigarettes means that you're more likely to get cancer. It just means there's a correlation. So there's the whole notion of correlation not being causation, but correlation does mean something. And that's something that scientists use visualizations to sort of bring to the surface and to explore and to raise additional questions about their data and to present their findings in an interesting way. And the most an interesting aspect of that scatter plot on the right, the figure 2, you'll see that there are two dots for the United States. The top right one, which is almost, I would call it an outlier because it's the highest rate of cigarette manufacture as well as lung cancer. But then in the bottom left, you see there's USA never smoked. So they broke out within the United States population, those who never smoked and those who at one point smoked. And the difference is drastic. Although the number of cigarettes manufactured per adult was the same. So that's incorporating the fact that if you smoked, your chance of cancer is that much higher. So like I said, visualizing data can illustrate a pattern that you can otherwise miss. It's easy to miss looking at something. So now another classic example, and as I mentioned, I'm the Maps and Spatial Data Curator, so you're going to see a lot of maps as we go here. And this is the Jon Snow Map. It's not a Game of Thrones thing, but it is a map created by a doctor during an outbreak of cholera in London in the 19th century, where he mapped the fatalities due to cholera within, this is I think on London's West End, and correlated and showed that the number of deaths occurring due to cholera were concentrated highly around one particular water pump, because that's how water used to be distributed within a metropolis like London. It wasn't that at least for the poorer people, it wasn't the case that you had plumbing fresh water into your home. You had to go down the street to get fresh water. In this case, that water wasn't so fresh because it turns out that it was contaminated by sewage, which was leading to the cholera outbreak. And let's see a little zoomed in. You can see right there in the middle that says pump, and these little marks, the little black marks, indicate deaths. And you can see, just looking at it this way, without any fancy visualization work or anything like that, it's just a map with little hash marks showing deaths, and you can see it's very much centered around that particular pump. Because if you look elsewhere on the map, there are pumps still visible elsewhere on there, but they are not nearly as close to the bullseye as you can see this Broad Street pump is. And this is frequently deemed the birth of what is the field of spatial epidemiology, which is thinking of the mapping of disease, which is something that's become relevant in the last 6 months or so. Increasingly relevant, not that it was not relevant before that. Okay, let's talk a little bit about the different types of charts. And really, sort of the king of data visualizations and sort of the overarching granddaddy, I would say, is the time series. And I'll quote Tufte again here just because he's so eloquent. With one dimension marching along to the regular rhythm of seconds, minutes, hours, days, weeks, months, years, centuries, or millennia, the natural ordering of the time scale gives this design a strength and efficiency of interpretation found in no other graphic arrangement. And that is absolutely true. Now, if you remember that data, the data table I showed very early on, the giant mass of just indecipherable numbers and letters, this is that same data represented using a line graph. And this is a very common thing to see. This is not a real unique visualization. This is something I made using data available for free online, where the different lines represent different types of tax collection within Oklahoma, and this is covering the period from 1990 to 2015. And you can see that the x-axis, which goes from the left to right, that's showing time, so that's as the years go on, and the y-axis shows the actual data being plotted. And that, in this case, it represents billions of dollars. So you can see over time, you can see where the Great Recession of 2008 and on had a huge impact on tax revenue collected, especially income tax. If you look right here, that just took a nosedive and slowly recovered. And so that's a line chart. Here's another one. This is showing job growth and loss during recessions, and how the shape of these different recessions and the recovery or lack thereof has differed. And you can see that the point of this series of visualizations is that the coronavirus crisis is different. And that's because if you look at that purple line, that represents the lowest earning 25% of the working population. And that, you can see, has lost more in terms of number of jobs compared to any of the other quartiles, and has recovered the least in that same period of time. And you can see, especially if you look at 1990, there was actually growth amongst the lowest quartile 6 months in versus today. But you can see in general, 2001 and even 2008, there was a relatively well spread out, not drastically divergent impact, but that has been upended by the coronavirus. And when we think about it, if you think about it, it's a very, I wouldn't say obvious, but it makes a lot of sense as to why that would be the case. Service jobs have been impacted way more than anything else. People who can't just work from home, can't telecommute, can't talk in front of people on a webinar about data visualization. People have lost their jobs, and those jobs are very slow to come back, if they will come back at all. Thinking about movie theaters, indoor dining has become so much less of a thing. The restaurant industry has suffered very greatly and is in dire straits. The airline industry, just anything to do with tourism, with service jobs, consumption, has really has struggled greatly. Okay, then we have bar charts. This is maybe the most simple of visualizations, but it also can be highly effective, and it allows you to compare discrete categories. So you can see we have different teams in this. On the chart on the left, we have different teams, and then we have the number of points they've scored during different periods. And although bar charts can show change over time, it often, if you're showing time, if you are using a bar chart, you'll probably be better off using a line chart. And that's just because if I'm looking at a bar chart that shows change over time, mentally I'm basically drawing a line from the tops of those bar numbers to from one to the other, so I'm creating my own mental line chart. So don't make people do their own work, do it for them. Present both of them if you want, that's fine, but you don't want to force them to do things. Pie charts are generally, they're sort of like everyone kind of makes fun of pie charts, at least when you talk to data visualization people. And that's honestly with good reason. It's very difficult to compare the values. You tend to have a key with a bunch of colors that you have to then look back and forth to identify what's what. Usually to make it any degree of usefulness, you'll label it with the actual number as well as what the value is, and in that case, what's the point? You're better off just using a table. Here's a tweet comparing pie charts to Nickelback, which is kind of lame. I mean, this was 2013, so many of you were probably my child's age at that point. That makes me feel old. Anyway. Okay, scatter plots. Scatter plots are really great, especially when it comes to bivariate comparison. It's the king. And you can see just these half dozen little examples here show if you take a bunch of data points and throw them on an x and a y axis, you can see, is there a correlation? Is there a relationship between the different traits that you're mapping, that you're charting? And so you can see that strong positive correlation goes in a straightish line from bottom left to upper right, and then everything in between. So here's an interesting scatter plot where it's not so much showing it's showing a relationship, but not quite in the same sense. And so it's showing different metro areas, so the 50 largest metro areas in the US from 1980 to 2011, what percentage of the labor force in that metropolitan area is coming from manufacturing. And so the y-axis, over here on the left, that is showing what the share has been in later decades, whereas the x-axis shows what manufacturing had in 1980. And what this means, and you can see this dotted line here going perfectly from 0, 0 to right, the top right, shows that is the line at which you would have either the same level of manufacturing in 1980 as later decades. And if it's above that line, it actually went up, so that manufacturing share increased over those decades. And if it's below that line, it means that manufacturing's share of the labor force decreased from 1980 to 2011. And so this chart really, really effectively shows the decrease in manufacturing, at least amongst the largest metropolitan areas in this country. And you can see there's three separate trend lines showing the different decades, so 1990, 2000, and 2011. And that shows just how those changes continued over the course of those decades. And there's perhaps one or two, maybe three metros that had, I think one that just clearly had any kind of growth, and just two others that maintained their relative share of manufacturing. Everything else dropped. Okay, another type of chart I want to highlight is the 100% area chart. And this is a really useful chart as we approach election season, especially in this country where we have two dominant parties and no really viable third party options, where when we're mainly interested in relative values, or that the two add up to 100%. So you can see this is would be useful to show how has voting changed in a given state over years. What percentage of the population voted for the Republican candidate, how many voted for the Democratic candidate, and things like that. Here's another example, and I think this is a really effective one. This is a time series represented as a 100% stacked bar chart. And these different colors show what percentage of the weekly deaths from COVID-19, and it's broken down by the levels of urbanization within that county. And what this shows is that since February, since the beginning of the pandemic, large cities have borne a much smaller share of the percentages of deaths versus medium-sized cities and smaller cities. And I think, again, this, if you think of it in just anecdotally from your own experience, there is a there is a trend showing. When you think New York, we think L.A. That at that earlier on, that's where the pandemic was really centered. And as as things have progressed, we've seen the pandemic spread into smaller locales. It's not the kind of thing that's spread in a consistently diffused way. It's something where we've seen what's called hierarchical diffusion, where we see the pandemic's begun at the largest cities, and it's sort of moved its way down through those the different levels of density and urbanization. And one last 100% chart is showing how over time there's been a change in the health insurance industry in terms of how the types of health insurance coverage people are getting. And the particular focus of this chart is talking about high deductible health plans. And those are represented in red. And you can see from top to bottom it goes from the oldest data, and then the bottom is the most recent data. So this is going from 1988 to 2015. And in a really nice touch, I think, if you look at the top here, is there's more white space between the first 3 or 4 bars on this chart, and that's showing that the data has gaps. So when you get down to 99 and on, we have a line per data point. But as you are, and then you can see where the high deductible plans have grown, and you can see where HMOs reached their peak in the mid-90s, and those have shrunken And PPOs, this yellow here, has that's become that has been the dominant method of health insurance delivery, but you can see that high deductible plans are very quickly becoming more popular. All right, now let's talk a little bit about maps. Here's a map illustrating the spread of Walmart over time. So you can see back in 1968, 67, started in near Lafayette, Arkansas, Fayetteville, and how it just spread across the country. So that's a fairly compelling portrayal of taking, again, a time series. This is another form of time series visualization, change over time, and showing how this one brand has enveloped the country. Here's another map. This is an older map, not a interactive or dynamic map, but it's a map showing major land uses in the United States. And you can see there's a really incredible amount of detail in this map. And really, like I was talking about before, if you have, when you have maps, or when you have a huge amount of data, we're talking about data density. If you can try to imagine representing this map as something like an Excel spreadsheet, that would be very difficult. And if you did, it would be almost incomprehensible in terms of what you're looking at. Here's one last map, and this is what's called a cartogram, where you have, where you take a map, but the actual size of different features on the map reflect something other than their actual area. So in this case, we've taken a map of the world and we've distorted the size of different countries based on their coffee consumption from the year 2014. So you can see big ones, the US, Brazil is gigantic, Western Europe, Eastern Europe, very large. But also, if you look at Scandinavia, which are very small countries in terms of population, they are drastically larger, and that's because Scandinavian cultures consume vast quantities. I think they have the highest per capita consumption of coffee. I think Finland, Sweden, Norway, and then Brazil tend to be the dominant ones when it comes to per capita consumption. And you look to the continent of Asia, the continent of Africa, coffee consumption is much lower, and I'm guessing if you looked up tea consumption alongside that, there would be a strong, I think there would be a correlation between the two, a negative correlation. So here's a really interesting sort of meta chart that it's a flow chart showing ways to ask about your data and to decide on what sort of a chart you should make in order to best represent your data. So you can see you say what you're trying to represent, you answer a few questions about the data, and then it'll spit out an answer about what you ought to look into. And that's just a really useful thing. Something, if you were ever to want to make your own data visualization, something you should consider is how should I represent this? Should I represent this? What's the point here? Now, we're just going to kind of make fun of some bad visualizations just for a few minutes. It's always kind of fun. So really, the point of this next section is to not embellish and to not add just a whole bunch of junk. Chart junk is what you can think of it, to your graphs. So now, I hate to pick on the poor pie chart again, but this is an even more egregious example. If you take a pie chart and you make it 3D, and not only 3D, but it has a nice gradient color to it, that is just utterly unnecessary. And it makes it even more difficult to compare. And honestly, because now you're introducing the notion of volume into the equation, it's muddying the waters even further in terms of how someone is supposed to read this graphic. In general, you can see 3D graphs are just not a good idea. You don't need to pop your bars out. There's no need for it. It's something that I blame on Microsoft Word and Microsoft Excel from 1999. We all got seduced by the notion of 3D graphs, but there's no need for it. And this one is obviously, I made it bad on purpose, but you don't need all of those lines showing the breakdowns. Unless you really need that exact value, you don't need to label each data point with the actual value of it. If you need to do that, you need to reconsider, why am I creating a graph if I think people need to see the exact numbers. And let's move on to just some outright bad visualizations. So this is really one of my favorite ones. And it's showing, it's a bubble chart, so where the bubble indicates, so that's the circles indicate the total capacity of wind energy developed or available within a given state. But then it's showing the position of each bubble is where they voted either for Donald Trump in 2016 or for Hillary Clinton. And you can see there's a strong negative correlation between there's those who vote, states that voted for Trump did not vote for Clinton, and vice versa. So this, which is sort of an obvious thing. So the question is, why did they decide to plot this data on an X and a Y axis like this? I just don't know. And really, I understand people who work in newspapers have deadlines. They have to turn things out very quickly. And so they often are the source of these sort of ridiculous maps and charts. And that's just, in newscasts frequently, that's where you'll see maps showing like Switzerland and it's I don't know, Sweden, that sort of a thing. So I feel for them, but also it's okay to make fun of them a little bit. So here's another one, just another pie chart, and this is showing, you can see, you probably can't read, I can barely read the labels on this chart, and I am sitting right in front of it, but it's showing coronavirus cases in the UK, and there's just way too many slices, and this is just absolutely useless. Now this one's really pretty great. This is the classic case of someone flipped around what we're representing and what you're showing. This is showing ostensibly the predicted growth in the global swimwear market broken down by fabric. But you can see there's a shift from polyester to nylon to neoprene and so on, where, and then the two colors are actually representing the two different years. So I'm thinking this is a case where someone told someone they wanted a chart and they just didn't quite nail it, because this should be a bar chart showing polyester with a lower bar for 2018 and a higher one for 2024 and so on. Like, you can sort of get the idea, but the fact that these items are linked together, it's just no good. So don't do this. You got to avoid it. Okay. Now I'm just going to start wrapping up. I want to share a few resources with everyone. Tableau is really a fantastic tool for creating data visualizations, dashboards, things like that. You've probably seen a whole lot of Tableau visualizations over the last 6 months during the pandemic. As members of the academic community, they are very good about giving us access, so it's something you could check out and learn for free if you wanted to. If you're more of a coder, if you know JavaScript and want to really get into the nitty-gritty, there's something called D3, which is data-driven documents. And that allows you to code interactive visualizations that can do almost anything you want. if you can, as long as you can figure out how to get the code to work, you can do it. It's really remarkable, and some of the if you've seen some of the data visualizations that the New York Times has put out over the last decade or so, those are either created using D3 or the predecessor to D3, because the guy who created that software used to work for the New York Times in their interactive graphics department. And then here are a few references and links. If you want to see an interactive version of that Menard map, I linked to that on there. And then flowingdata.com is a great place to go if you just want to browse and browse through great examples of data visualization. It's going back to, I think, 2007 is the first post from Flowing Data, and they're still going strong. So it's really a really nice place to go. If you want to check out Edward Tufte, who I quoted a couple times, his book, The Visual Display of Quantitative Information, is highly readable and a really fantastic place to go to learn more about visualizations and what you should and should not do when it comes to it. And I'm going to end there, and thanks for everyone for listening, and I would take any questions that we might have.
Thank you so much for watching Tech Tuesday at 2. Don't forget, all of our past Tech Tuesdays are on our YouTube, so don't forget to subscribe. See you next time.